Alright, so today class we will be talking about derivatives.
What's a derivative?
Well, Liam, a derivative is known as many things. For one, it can be known as a slope. It can be known as a rate of change. And
Who's
it
that?
can also be known as a tangent line, or a line tangent to the graph.
You spelled tangent wrong, sir.
You know what? This is math. Now, if you may be wondering, well, what does that have to do with a function? Well, let's say we have,
What's a tangent line?
let's say we have the function x squared, right?
Whoa.
Well, the slope, as you remember from algebra, is rise over run. And so for every point, it goes up and across.
Oh.
That is the slope. Now, the rate of change is for every time x changes, what y is. That's the rate at which it's changing. Pretty simple stuff. The tangent line is the equation of the line that is tangent to the graph at one point. So at this point right here, it would touch it at just one point. Now, in terms of limits, the definition of a derivative would be the limit of a function of x plus h minus function of x over h as x approaches h. So let's take, for example, the function x squared. So if I plug that into here, I would get the limit as x approaches h of x plus h squared, because I would be plugging the h into the function, minus h squared, or x squared, over h. Now, if we simplified this, we would get x squared plus 2xh plus h squared minus x squared over h. This minus x squared and this positive x squared cancel out. Everyone follow me?
Bless you!
And then we can take out an h out of everything because it's divided by h, and all the terms have an h. So this h cancels out with that and that, and we are left with 2x plus h.
So wait, what's the derivative?
That would be the derivative. Well, Liam. Can you sit down?
Oh, okay.
Well,
I'm gonna go find
Liam.
my family.
Well, Liam,
His
how about we
dad
have
left.
Miranda explain some simpler ways to find the derivative?
A simpler way to find derivative is through power rule. So the equation is nx n minus 1. So let's start off with an equation.
Hey, he tried to
Yeah.
kiss me in the mouth. He tried to kiss me in the mouth. He tried to kiss me in the mouth. You see that?
Okay, so we're going to start off with x squared. Now 2 is our n, so we're going to plug in. We're going to plug that in. It's going to be 2x 2 minus 1. Okay, so we have to solve this, which is going to be 2x to the 1. Okay, and that, just rewritten, is 2x. And we're done. That's the answer.
How did you get that?
Well, like I said,
The power rule.
okay. Our next problem is square root of x. And although it may seem as it's to the first power, it's not, so don't write that. Okay, so square root of x can be rewritten as x to the 1 power. Okay, now this is still our n, so we're going to plug it back into the original equation, which is 1/2 x 1/2 minus 1. Now we need to work this out, so that is going to be 1/2 x to the negative 1/2. Everybody get that? Okay, so since this is a negative, we can rewrite it. It can be rewritten as 1/2 1 over x to the 1. Okay. Now, since we multiply that, it's going to be 1 over 2 x as our final answer. And we're done. Okay, so we're going to start on our last one. It's going to be x cubed minus 4x. And even though this seems difficult and rather more difficult, we can break this up into 2 different parts. So we're going to start with x cubed. So again, it'll be x cubed, and we'll use the same rule we've been using, nx to the n power minus 1. So 3 is our n, so we're going to rewrite that as 3x 3 minus 1, which comes out to 3x squared. And we're done with this part. Okay? So we're going to move on to the second part, which is minus 4x. Okay? So we have minus 4x. And even though it's not written, it's implied that there is a 1. So this is our n value here. So we're going to plug that into our equation. It's going to be minus 4x 1 minus 1. And we're going to work this part out, which is going to be negative 4x to the 0 power. And anything to the 0 power is 1. So that means it's going to look like this. 1. Okay? And we just simplify that, and that's going to be negative 4. Okay? So we're going to put all this together, and it's going to be what we had before. 3x squared minus 4. And we're done.
Well, what if you had to derive something that was a constant?
How do you do that?
Well, Zach, let's take the number 7 for instance. It's a constant because it doesn't have any x values next to it, or any y values, or any variables at all. So, let's say we have 7. Alright? You can assume that there's an imaginary x here to the power of 0, because x to the power of 0 is 1. So it wouldn't affect the value of the 7. Right?
Interesting.
So, if we use power rule, we bring that 0 to the front, and we get 0 times 7 times x to the negative 1. Well, 0 times anything is 0. So it becomes 0 when you derive a constant. Let's try the number 1,900, 1,800, whatever that is. 764. That number.
You know where her mind is.
And let's say we want to derive that. Well, it still has that imaginary x next to it, to the power of 0. Bring the 0 in front. 0 times that is 0. So then that's how you derive a constant.
Every constant is 0, sir?
Would deriving a constant make my dad come back?
Maybe, but now let's say you had something a little more difficult. Let's say you had 2 functions, 4x squared minus 1 times 3x. How would you derive something like that? Well, you would use what's called product rule.
I'm like the dumbest people in my class.
Now, product rule has another formula just like power rule, and this one is u prime v plus v prime u. U being the first equation, v being the second equation, u prime being the derivative of the first, and v prime being the derivative of the second. Does everyone understand?
No!
Are you saying the ABCs like that?
A, B, C, D, E, F, Q.
My mom taught me my ABC.
Sure, come right up.
Daddy, I can't
Alright,
see
so you have 2 functions here that are distinguished by the u and the v. This being u, and this being v. Okay, so as you can see here, it's 2 functions. So what we got to set up first is the u equals v equals, and what the u prime equals, and what the v prime equals. V prime being the derivative of each.
I like the way you talk.
So
You know
first we will
Adele?
start with
Do you know Adele?
You want to know why I use
anyways. So here's the 2 functions that we've established here, identified, u and v. Now we're going to take the derivative using power rule that you were taught earlier. first you're going to bring this 2 over, so let's go 4 times 2x to the 2 minus 1. Derivative of constant is 0, so you get minus 0. And this will simplify to 8x. So that's your derivative of the u prime, or u function. So here's the v prime function right here, and this is going to be also a power rule, which is the 3x. Well, we'll should go to just 3. Yeah. All right. So now we're going to have to plug this into the equation.
Remix.
After we find the values of each variable. So now we're going to plug this in. So we have 8x times 3x being u prime and v plus 3, which is a v prime, times 4x squared minus 1. This will all simplify out to 24x squared plus 12x squared minus 3. Alright?
Oh my god.
Anyways, so 36x squared minus 3 is your final solution.
And that, students, is why my mom said I'm a mistake. Any other questions?
Whoa, this is not calculus. You can go sit down, Mr. Blackzack.
Oh, yeah.
We're going to continue our lesson. Thank you for your input, though.
That was my
So
mom.
that was invigorating.
All right.
It
So
made me
next
really
thing
question my morals.
on our curriculum is quotient rule.
Quotient. Sir, my name begins with a Q-U.
Oh, I don't care. Well, quotient rule is used for when you're dividing a function. So let's say we have f of x over g of x, or u over v. This is what we would use. We would use quotient rule. And the rule for quotient rule is u prime v minus v prime u all over v squared. Wake up, Liam. All right?
Yeah, I think I understand this one.
All right, Liam, come up and give it a try.
Alright, so now I guess we're going to do some problems about this rubbish quotient rule. Start off with an example. X plus 2 over x squared. And this is, as you can tell, in the format of the f of x over g of x. This being the u. this being a u. And this being your v. So, what we are going to do now is distinguish the u prime coming from here and the v and v prime. So we're going to draw our little table, and that will be u equals the 3x plus 2. V equals x squared. Alright, so now we can find the derivative of each u prime being 3 because of the power rule. The constant goes away. N minus x, n times x minus x. Would you like to say that? Alright, so anyways, the v prime will be equal to 2x because of power rule again, taught by the lovely Miranda Garcia. Alright, so now we're going to plug this into the equation. So we have u prime, which is here 3, times the v, which is x squared, minus. Thank you. So back to the problem. We have the v prime times the u, which is v 2x times 3x plus 2. Don't forget your parentheses. Don't forget. Yeah, because then you have the negative eventually distribute and all that good stuff. Then you have the v squared, which is right here, squared. So you have x squared squared. So when you simplify this, I'm just gonna go over here. We have 3x squared minus the 3x squared minus, distribute the 2x, so you have 6x squared plus 4x, and then over x squared squared. So when you have them multiple exponents, you're going to multiply them across, so you have x to the 4th. Now you're going to have to distribute the negative. So let's say this is positive, negative, negative. So you have 3x squared, oh, and you can take away the parentheses. 3x squared plus a negative 6x squared, so you have negative 3x squared minus 4x over x to the 4th. Any questions, class?
So there's some trash on